Hello there, Captain on deck. Today's Wednesday, means that it's time for Streaming Frontiers. Streaming Frontiers where no data streaming engineer has gone before. My name is Viktor Gamov, and welcome to the show. Welcome to the show where things are happening live, meaning you get to participate, and I would not feel myself totally alone in in this room. So before we start, so let's test that everything is working. Make some noise in the comments. I will check on my side if I see everything is happening. Hopefully, yeah. So it looks like we have a connection in LinkedIn. If you come in from the LinkedIn, please comment and write something in the comment section. If you're watching us in YouTube, do the same. That would be great thing to know if you are joining us. Okay, so if you joined for the first time, it's fine. It's okay. I will explain what is going on here. Let me see. I see at least like a few people actually watching. So hopefully there will be more of you. Now, the Streaming Frontiers live show where I'm exploring different streaming technologies and how things would be applicable for Kafka, for stream processing, for Flinks, and all these kind of things. And I'm trying to really try. I'm really hard to keep this once a month cadence. So that's why it's kind of like it can be 1 week, it can be another week. So because of the traveling schedule and some other things, but I'm still on this journey for every month. Okay, so we start getting some people in LinkedIn. Anurag, welcome for Streaming Frontiers. As always, before we start, so we'll check if the sound is good, the sound is okay. You can hear me well, you can see me well. Write down in the comments where you're coming from which galaxy, which planet, and yeah, so all these things. That's great here. All right, so area, welcome to Streaming Frontiers. Thanks for shout out. Welcome for the first timers. Hopefully it's not going to be a last time. So yeah. Before we jump into the subject, I was breaking down the subject for quite a few episodes already. It is a subject about how we're gonna query streams. I think it's a quite general question how people have, but also it's a very the answer will fascinate you because there's so many different technologies that can do this. But we're going to start with some housekeeping items. First of all, I know about you, but I'm pretty excited about Current. Current is happening next week in New Orleans, 29-30. It's gonna be cool, guys. It's gonna be awesome. It's gonna be awesome things that's gonna happen in New Orleans. Hopefully, I will see many of you in person there. If not, it's okay. It's okay. Maybe next time. If you kind of like decide to immediately today, if you decide, okay, so I want to go I'll buy tickets. I find a good ticket. DM me in LinkedIn or on Twitter or X, Instagram. I'll send you a coupon code so you can join us for free. Just like pay for tickets and stuff. There's gonna be cool things. We do have 100 speakers. It's gonna be for 2 days. We're gonna have 2 awesome keynotes. The first day is gonna be a general keynote about some announcement on the product side of things. Sorry, on the product side of things, but we're also going to talk some developer-focused, developer-specific things. And on the day 2, we're going to have some fun with a developer keynote. I'm working on some exciting for me demo. Hopefully, everyone who will be in the room also will be excited about this demo. All right, so let's see who is here. All right, so Mini, welcome. That's Mini is my partner in crime and keeping things in check in the background. It's good to have you. Oh, the person that I haven't seen for a while, Robert. Welcome to Streaming Frontiers. Probably Robert saw my announcement about the Pinot. It's just like, okay, so I gotta be there. Deborah from Barcelona. Welcome. It's good to have you here in the Streaming Frontiers. Maria from Toronto. It's the same time zone as I am, also East Coast. Welcome to Streaming Frontier. All right. Apart from doing some cool things on the conference floor, as always, we're doing some unofficial things. I wrote this in my LinkedIn. I almost lost this post. We are going to organize an unofficial run if you're in this type of jazz. It's going to be also early in the morning, so you will not be swamped with the other things in the conference. So we're gonna do a 5K-ish type of distance. It's gonna be on 29th and the 30th at 6 a.m. in the morning. We're gonna start. Join our Strava club, and you can find a map where we're gonna be do our running. It's gonna be cool. It's gonna be cool. All right. So with this, I don't have much of an announcement. No, actually, I do have. I have one announcement that few friends at Confluent developed this pretty cool website called Flink Watermarks WTF. That will, you can play around this with it requires its own. It requires its own stream to go through all the things. Maybe I will bring Robin in future episodes to talk about this. But this website will teach you all things about watermarks, Flink watermarks, how they work, what you can use it. Go to this website, easy to remember, and play around. There's interactive learning panel, I would say, and you can see what's going on the screen, and there will be some cool animations that show in the data streams and how different Flink watermarks strategies will affect this, how it will affect your processing, and how we can use this in your stream processing life. I hope this is something that you will enjoy playing around with. See, there's some dropped events and stuff like that. So it is a pretty cool website. Just go there, play around, learn about Flink watermarks, and we can get back. We have one big episode about Flink, I promise you, and I already kind of like going closer to this. Now, as always, previous episodes you can find in Confluent Developer YouTube channel. This is where we are going live right now, as you can see here. This is pretty cool. Some people here. We just started new Confluent Developer podcast. Confluent Developer podcast. We are interviewing some very interesting people about their the origins of their technology excellence. Let's put it this way, and we talk about some interesting things what they did in life and interesting things that made them who they are. Gotta check it out. Now, let me quickly bring some slides so we can set our stage. I switched, or I would jump some of the technologies that not very interesting probably, or I will maybe don't know much about those. and I'm going to go with this one. All right. So with real-time analytics database. So previously, previous episodes. In the previous episodes, we talk about a few things. So I showed you how you can use Kafka streams for. I showed you how you can use Kafka built-in technologies to do streaming to places where you can query. Like usually it's a relational database. We talk about Kafka streams. With the previous episode we talk about Rising Wave, which is a streaming database example. And now we're going to talk about real-time OLAP. So what is that? Like, how it affects and what it does for our stream processing. Before I rejoined Confluent, I spent some time at a company called Sartree, which was a company who was actively working on this open source project of Apache Pinot. And this is the time where I actually personally learned a little bit about this new category called real-time analytical software. And essentially, it feels like maybe it would be similar to streaming databases that we discussed in the previous episode, and it is very similar to streaming databases. Whoops, something crashed. That's fine. That happens. It is live show, so things happen. I should not move things around before the show. Streaming analytical databases. They use SQL. That's cool. Streaming databases use SQL as well. They are providing the ways how you can integrate with streaming solution directly without any without any connectors and stuff. So integration with Kafka in stream sources is a must. Is the kind of like absolutely required. Now, and there's a couple things that very important. Analytical queries usually executed somewhere in the batch when the data would be fully available. That will create some latency or freshness. Maybe also it will create some data that might be not fully baked. It's not everything would be ready in time for our queries. So the real-time OLAP is actually get the data in analytical use case, but in real time. One of the examples that we were using to talk about real-time OLAP, in LinkedIn, if you think about this, it's actually very interesting. Many things that expose to user, as you and me, when we go into, say, when we go into our feed in LinkedIn, say you want to see what is happening here. So there's different interesting events happen, and surprisingly enough, this user feed is actually very much analytical use case. All events that happen in LinkedIn, they come in the form of events that happen to land in one huge Kafka cluster, and these events will represent people, changing their bios, people posting something, and all these events. There's like millions of events happen like every minute. Now, to generate the feed, we need to think about this again. All these events will represent one big multi-dimensional table that will include who wrote this, what kind of post, or what kind of event this is. And in order to generate this feed, is essentially a analytical query with a bunch of filters and a bunch of fields that we need to do. And now this data needs to be exposed to either API on the front end. It needs to be exposed to the way how the front end will read this. And ideally, we want to get results that are fresh with the seconds. So that's why high concurrency, because all this data that would be stored inside the Kafka will be available or will required by many people to be used. Low latency, because you don't want to, this query will sacrifice data load, because people, this stuff would be exposed to people, will be exposed to users. So this is why sometimes real-time analytics calls the user-facing analytics, something that you expose immediately. And we can use this not only with streaming sources. There's a plenty of a batch of related data maybe stored, maybe some sort of, I don't know, the different dictionaries that can enrich our stream with things. So we want to deal with both streaming and batch sources. So that's important. So with the real-time OLAP, we're dealing with real-time data, and we're going to be exposing this real-time data. And in this case, the responsibilities are shifted from analysts, usually who build the reports, building these dashboards for higher ups or stuff like that, to users, which users use this analytical data to make decisions. Another use case that LinkedIn used is who viewed my profile. Who viewed my profile works exactly the same way. It is naturally analytical query, multiple dimensions of data that are available inside Kafka, and people wants to see this immediately, because I don't want to wait until, I don't know, couple days after someone checked my profile, and after that, oh, okay, a few days ago they watched saw my profile. I want to do this in a real time. So this is where Apache Pinot takes its roots. So Apache Pinot is open source project. You let me know in the comments. I'm gonna start. This is the category. There's a few other players available, and it's actually like a big deal. I'm gonna start with Pinot because I know what I'm talking about because I was using this. But also I'm thinking maybe talk next episode talk a little bit about others, like a ClickHouse, for example. It's a good example of also real-time analytical database that also has some integrations with Kafka and things like that. So write down in the comments if you'd like to see the episodes where I will be talking about the ClickHouse. Now, Apache Pinot, as you can see here, gets the data from multiple different sources. Data comes from streaming sources like Kafka, comes from the batch sources, and it has a very SQL-like integration. There's some connectors. Pinot itself provides storage and it provides compute, and those things are disaggregated. In Kafka, we have a storage and compute baked in the nodes. Our brokers serve queries and also perform tasks to do some storage things. So data would be written in logs. In Pinot, those tasks would be spread across multiple different components. So I decided to build some application. To be honest, I actually wipe code this application a little bit, and it turns out to be not very bad. If you go this, it's called Real-Time Analytics with Pinot. That's the repository that you can use. You can learn. You can get all the sources. In this case, it uses all. It uses all open source components. You will be able to run this, but let me show you a diagram. It doesn't show me diagram. Okay, let's see if my IntelliJ will be able to show me a diagram while I will be talking about this stuff. Yeah, so Can I do this a little bit bigger? No, I cannot. Oh, okay. So what I can do, I can do mermaid online, my diagrams on mermaid. So we can just copy this from here. And I'll show you how this demo would look like. So online, flowchart and diagrams editor. Perfect. Boom. All right, so a couple things here. There will be some data. Data generated, data will be in Kafka, there will be some events. And we want to extract these events and turn it into some real-time insights. Specifically, there was some data generator that will generate different events for our system. I will be using Flink here a little bit. Flink is not going to be the main player today, but it will do very important things, and I will explain a little bit after. So, but think about this for now, that data available in Kafka topics that will be used in order to feed our dashboards. I will be using Streamlit as an example. Streamlit it's a Python framework. Pinot has great Python driver, and it works, integrates nicely. All right, so let's see, look here, if my PS. Yeah, let's start from, stop. I will do this from very beginning. I kill everything. We'll start from scratch. And while I'm on this, all right. So we have a few more people. We have Ivan Alex from Brazil. Robert needs to refresh to begin watching. Yeah, probably you should go and watch the previous episodes. Every episode's available in Confluent Developer. Confluent Developer YouTube channel. If you go to live, all the recordings are here. All these live recordings, you can find it here in Confluent. Okay. Can I do this a little bit bigger? Let me do this a little bit bigger so you folks can see this much nicer. The one of the tools that I use to make sure that everything is people can see well. You just watch this on your phone. You watch in the phone and you will see how good is your phones and how good is the rendering. Okay, easy to drive demo. There's make files that allow you to start the things. Yeah, so the mermaid, it is a kind of like an ASCII style of defining graphs, and it gives nice diagram. Usually it has integration on the GitHub, so this thing would be rendered on the GitHub. Maybe it's because I use ASCII doc and it is not working out of the box. But if you will be using this with Markdown, this will be rendered on GitHub, so you can embed these diagrams to your repository. So, and let me open this one. I open new page, so I can open a different diagram. It also allows me to draw sequence diagrams, so I can see how data flows from a different component of the system. We're gonna explore this right now while this will start. It has multiple different components. Pinot has a cluster with 3 different components: servers, brokers, and controller. As I mentioned earlier, in Pinot, servers will be responsible for storage, brokers will be responsible for querying, and the controller is responsible for controlling this circuits. Now, with Pinot, you have ability to scale different components differently. If you need to increase throughput of your queries, you just increase number of servers, brokers. Or if you need to store more data, you can increase number of servers, and they will be, you don't have to have an exact number make status. It's up and running. Everything is running. Let's see. The servers are running. Kafka is running. And let's see what is available. I'm gonna use. Oh, I can use VS Code here. I can use VS Code extension to connect to my Kafka cluster. I can definitely do that. Let's see. By default it uses Kafka UI, but I don't want to. What is this? What is this? What is happening? I guess we got to use whatever we got to use. Kafka UI. Let's go this one. Browser. So we have a local cluster, number of topics, and inside the topics we have a raw events, and raw events would look like this. Again, fully data generated, some user ID doing something on the website, clicking around different products, so we can analyze this data. So imagine situation on the website, everything that user do would be captured and pushed into Kafka topic. That's basically what everything you do on LinkedIn will be also captured inside the Kafka. For some reasons, it's not. Let me kill Visual Studio Code. Let me try it one more time. If not, I need to file. I need to find a complaint with Visual Studio Code team. Oh, it's just died on me. What is happening? Let's see. Activating extension. Okay, let's see if it's doing anything. Now, so what we're gonna do? There's a few things. Imagine there is messages that will include some information about how many users. So in this case, we have sliding window to capture like every minute how many users on the website, and this information available inside the topic, inside active users per minute. There's a topic with product analytics. It will have information about the value, product category, electronics, how many was views, how many things were added to cart, the analytical stuff. Something that maybe like a backend people would be interested. I don't understand why it is happening. Maybe there's update available. Okay. Okay. And no resources found. Why is this? Activating extension. Okay, so I want to connect to enter connection details, fill in form. Yes, local Kafka local host. What it says? It says 1992. And let's test if it's can connect to this server. Can it? No. TLS enabled. We don't need to TLS. In here we also definition mode none. Localhost 92. Why? Let's do test one more time. Maybe it's not available. Something is not working. It's fine. Like, we're gonna focus on this Kafka bot UI. Yeah, so this is UI that I use for this case. Something is wrong with my with my Kafka. As a matter of fact, let's see, Docker Compose. Where is my Kafka? No, it's 1992. It should be available. It should be available. Exposed. My bad. It's wrong. It's gonna be 292. It's gonna be. Oh, we go. Here we go. Here we go. With this cluster, we have our product analytics. Great. Why it is still this BS? Okay. Messages. So the way how this data came to be, imagine someone is doing the job for you. So you do have some sort of analytical queries for your data, and based on your data. In this particular case, I didn't tell you this, but the what I was want to say, yeah. So in this case, I do have a Flink jobs running in behind, so they will take the raw events, will massage it, and will be preparing this data for consumption in our database. So let's see, our data is here, so I can do make validate all. AI is running. Pinot has things. We have topics are created. Make Pinot init. And we should have it now. All right. The way how the Pinot works with with Kafka, it is defined by table. So we're gonna map product analytics topic from Kafka in what Pinot calls real-time table. So in this case, we're gonna connect to this Kafka cluster, and Pinot has this concept of the real-time tables and not so real-time. I forgot what's the offline table. It's defined in batch. And in this case, we're gonna just read the data straight from Kafka. And the cool thing is that the Pinot with this integration, there's almost data will be available in Pinot table almost instantaneously. Once it is will be available in your topic with this Pinot consumer configuration, it will be reading this data, and data will be available in real time. Another thing that we need to define a schema of this data. What kind of topic information? Pretty much what we saw in here. So we need to figure out session ID, user ID, session start, session end, and the product analytics. Let's talk about product analytics, a different table we're looking. So product ID, product name, product category. We're defining this product ID, product name, product category. So inside the Pinot, this will be map our table. And the cool thing is that, like, if I will go, say, let's play down once again. Pinot comes with the great simple but still powerful UI dashboard. What they can see is multiple different components. We have one broker, one server, and 3 tables. We care about tables right now. We do have active users real time, product analytics real time, and user session real time. Real time means that those tables are connected to Kafka cluster. So as you can see, is active, meaning that there's someone is constantly reading data from Kafka. And now, say I can do active users. So if I just select count, how many records we do have from active users? Boom, boom, boom. 11. So if I will go to active users, we'll see how many messages we have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what does it mean? Data generator writes the data into Kafka topic. We do have a job that will be slicing these active users per minute. So for now, forget we have a Flink somewhere on the background that does the thing. So imagine someone or something that pumped this information in the topic. For the 10 minutes, it have a 10 different records that will define how many active users. See, just now it's 12. So if I go here and run this one more time, it will give us 12. So data in Pinot land in Pinot instantaneously. As soon as we'll land in Kafka topic, it will be available in Pinot for query. So if I would run the product analytics, and inside the product analytics, I already have some information that available. If I would run this in, say here, also we do count number of records, run query, we're going to 435 records about the product analytics. And if I would go here, product analytics, I should have a counter, kind of like gets the number of messages. It's here. It's here down below. It's 4, 4, 5, 6, and counting. So we'll run the query 4, 4, 8. So it is there. Again, this Visual Studio extension, it's pretty cool when it works. I don't know why. Maybe I have too many extensions installed, or maybe maybe it's another AWS thingy. Yeah, there was a lot of fun this week to figure out some of the infrastructure. Yeah. If you didn't know there's extension, you live, you learn. This free extension, courtesy of Confluent, is available for everyone in Visual Studio Code. It can connect to local Kafka clusters. So right now it's even connected to my open source. You can run local Kafka clusters. So come to this presentation more often. I'm showing some cool bits every month. Hopefully you will learn something. Now, let's get back to our data flow. So we do have this event generator. It posts these events in my how I can I close it somehow? Probably I can do this something like this. Yeah. So the raw events coming from event generator. Think about all these aggregation products, active users, and user session goes into Kafka topics. Now the Pinot will consume those topics and turn it into a table. And now we can see how our visualization would look like. And I am not printing this out, which is terrible. I need to. It's going to be 8.5, something like this. I got lucky. So, and now we using this. I'm using this the cool technology called Streamlit, which is Python script that reads data from Pinot. And it's not WebSocket. There's nothing really real time. It's constant polling of this data from Pinot, as you can see here. Now we can run some of the queries and visualize those queries inside our dashboard. So let's do interval every 5 seconds. So we can see total views will change. We can see how the revenue would grow. We can see where this revenue comes from in terms of the sources of revenue. So those things now inside the Pinot in these queries will be executed those queries will be executed inside the Pinot. So let's take a look how this would look like in real life. So there is an analytics dashboard that use this Streamlit. Let me show you what's a Streamlit. It's very good tool for very fast user-facing analytical data applications in Python. If it's a part of your jam. Not a big Python person. However, the LLMs were able to write pretty decent Python code for me. So in this case, connecting to my Pinot cluster, connecting to controller, And there's a couple things. Let's do this one. It has hash of things. Some of the components that allow to display this data will be available. So for example, there's different toggles available, and say in this case data will be refreshed. It will include some additional information, say what kind of data, so data ranges and all these things that will be passed down to Pinot and will be executed. So first call that we have. So let me actually copy this and run this directly by Pinot, and we'll see what kind of data we have here. So if I go here, it is analytical data. We go from the product analytics, total views, total cart ads, total purchases, total revenue. So when I run this query, it gives me all these results. One of the things that Streamlit handles here in this dashboard, this is the top key metrics that we're showing: total views, total cards, total purchases. We're also adding the time-based range check, so we don't need to display everything. We handle this information from data that will read from user controller, this component that will be defining the ranges of the data that we want to display. Where is it? Where is it? Product analytics. Yeah. So we will, based on this data for the last 7 days, we don't have enough data for 7 days, so we're going to be using the last 24 hours. So this data inside the Pinot would be correspond pretty much to whatever we have here in this dashboard. Oh, they start having some query visual nothing. Okay, JSON tabular. Okay, we're gonna see tabular. I thought that's gonna be oh, nice. Oh, this is something that I haven't seen yet. I updated last night in the time series queries. This is something that I haven't seen yet, but that would be cool to explore. Now, next thing is we're gonna see next query is also against product from product analytics. We're getting information about product performance based on let's run this query. So we will not be able to use where clause because the weird times. So we're not gonna do this. Let's see. Product name in the product category and number of views, say for customizable didactical average. That's what you're getting. That's what you're getting when you use LLM to generate your code, generate a reactive directional forecast. It's a book name. Optimized dedicated application in electronics. So there's some data, and again, the cool thing is that you're getting results almost instantaneously based on the fresh data. So freshness is pretty big deal for yeah, okay. So Robert says there's a visual query results allow you introspect query plan. It doesn't show me anything, so it shows no stats available. It's nothing. Maybe I should use tracing and the stats will be exposed. Robert, if you know how to enable this, let me know. Maybe we can show this as well. I haven't seen this. I should have studied this a little bit more. Now so this query will be executed, and we will see results of this query right here. That's what we will see. And the cool thing is, inside the Streamlit, you have ability to look inside this particular table. You can do some search built in. So it's pretty nice components. Everything will be refreshed and stuff like that. Now, next, next step is we're going into, again, we're doing the product analytics. We're trying to calculate a trend. So we could pre-calculate this information. We could pre-calculate this stuff in our case, but it's not. Let me quickly check something real quick in the background. Yeah, so this information could be pre-calculated, but since this database allows us to do this and data is already there, we don't need to do anything fancy. So it's perform like trend over 1 minute for the trend graph that we will be displaying. And there's plenty of things that you can do with Streamlit in terms of customization, visualization, and all this type of bits. It's pretty fun. So product, we're still doing product categories. Can we do something not with the products? I don't remember if I'm actually exposing something not with the product. So this revenue analysis, it's still per product. So we don't have anything with let's add something cool. So the product analysis dashboard, let's do something. What kind of data? Let's see what kind of data we have. So maybe we can come up with some user session. So what the user session does, run queries. User session, total spent, session ID, session start. There's user ID, total spent. Can we do okay, so let's wipe code maybe a bit and deploy this dashboard. No, not gonna do it. So it's almost in time. Maybe next time. So once again, we're getting some raw events. They land into different topics for product analytics, user session analytics, and active users. This information will be copied in Pinot. So it will be copied. So it will be stored inside the copy. If the Pinot would lose connection to Kafka, data still will be available inside the Pinot. That's kind of like a beauty. But also it creates additional space where you're going to be storing this data. And in this case, you will have ability to choose if you're going to be using your Kafka as your source of truth, or you're going to be using your Pinot, because Pinot will be exposed to users. It will be exposed to your dashboard, and this stuff will be available to query. It's going to be fast. Indexes are supported. All these things. Okay, so let's see. Robert adding some comments. Let's see. Your query with explained plan for. Okay, let's see. It's gonna be fun to see what we're doing this. We're gonna do what? Explain plan for. Something like this. No. Prefix or query with. Maybe I'm doing something like this. We also don't have this. Okay, we do have it, and now still no visual. I thought we will have some visualization for this very cool component that is not available. Again, need to probably read this up. Just updated yesterday and didn't have a chance to dig to all the new features. We slowly coming into this. One last component that I wanted to show you. Pinot has a very powerful and very cool engine that allows you to do even joins. You can run distributed joins um, in your Pinot queries. However, there's a couple things that not available in Pinot, and one of the things is that materialized view. So if this data will come into some sort of format and you need to massage it and save it somehow, like pre-save it, you unfortunately will not be able to do this, at least right now. There's no materialized view available. So one of the things you can do is to use something like Flink to maintain this materialized view. And this is exactly what we do in this. From the raw data, product analysis topic is basically materialized view. So I can actually parse this raw data and expose it to Pinot and store this as a query. So let me show you how this query would look like. In Flink, something is sent into user analytics. We need to product analytics instead of product analytics. So you can, I'm pretty sure you can run this this similar query. You will be able to run in Pinot. So you can have this raw table feed inside the Pinot, and you will be able to execute the query like this. I am almost 100% certain. The problem is that the rest of the query will be cumbersome because you need to build all these dimensions on top of this on top of the data. So there would be no way how you can maintain this. So that's why having something like stream processor on the other side that will be maintaining this materialized view, data will land in Kafka topic, and after that this Kafka topic will be available again for querying. So here we're going into the route kind of like not only for query stream but also combining two technologies. And I promise you I'll show you some other ways that was highly inspired of the things that we saw in the previous episodes. Specifically, hopefully in the Christmas episode in December, I will show you Flink and TableFlow, how these things will be solved in one place without kind of like a data movement, without data copying and things like that, or at least like significant data copying. Hopefully this episode was useful or at least entertaining for this subject. Let's summarize it once again. For high concurrency, low latency. So those queries with dashboards can be run by hundreds of thousands of people, and the system will able to handle this. Pinot drives or powers LinkedIn, powers some of the Uber Eats dashboards, some in other places. Low latency response would be super fast. The Pinot engine is also super fast. Data would be available super fast, so you can build, real-time dashboards like this with ease. I showed you how this Pinot can do streaming, but also batches available. I think somewhere on the internet there's a Star3 YouTube channel. There is a full-blown course about Pinot, how to configure this, how to deal with different other components, how to configure indexes, how to do ingest data with batches and stuff like that. So check it out. It should be very cool videos to look. Now, where is it? And Integrative Kafka greatly has conventional tables. Pinot has great starter index that basically can implement something that's similar to materialized view, and automatically pre-compute aggregations for configuration. Okay, yeah. So it's another approach. So there's always different different ways to doing similar things. Like adding Flink to the mix will complicate configuration a little bit, and will complicate deployment and stuff. However, it also will give you a little bit flexibility on some other things. So you can, you know, the same data can land not only in Pinot, can land in Iceberg. That will opens up use case with data lakes and data warehouses. We're not going to talk about data lakes per se in the show because I'm not a big expert on this, and actually I don't have any good example to run. The For people who just joined and asking this, how about Kafka streams KSQLDB to generate RASView? Go watch the previous episodes. I already talked about this a few weeks ago. KSQLDB, we're not talking about this guy anymore. I'm just kidding. So go watch the episodes. It's already there. Yeah, so we're moving on from real-time data. Again, if you're watching this and if you want to see me doing stuff with ClickHouse, very similar breakdown how I did for Pinot, write down in the comments, shoot me DM, let me know if there's something that someone interested to see. Otherwise, we're going to be slowly moving to the route with Flink and with Iceberg, Tableflow, and all this type of jazz. So we're gonna be starting this. It's gonna be 2 more episodes until the end of the year. So probably I'll do ClickHouse in November episode, and also in December we're gonna talk about Flink in Tableflow, how Tableflow will bring these two things together with operational data flow and operational estate and analytics estate without bringing ETL into the mix. So with this, my dear friends, thank you so much for those of you who joined me. Let's see. I do have this. What is this? What is this? Why I am not seeing? Can I see this? Yeah. This is your code for Confluent Cloud if you want to play around with these things. For this episode, it's not required. We didn't use anything on the Confluent Cloud side of things. This demo will be available on GitHub. My name is Viktor Gamov, and as always, have a nice day. I hope I'll see many of you next week at Current, or I'll see you next month. I'll see you in November in Streaming Frontiers. I will see you in streams. Take care, everyone.